Hi everyone, let's start by getting to know what carbon compounds are. Carbonyl compounds are a group of organic compounds that all share one thing in common, the carbonyl group, which is a carbon atom double bonded to an oxygen atom. This group is the key feature that gives these compounds their unique properties and reactivity. You will find carbonyl groups in a variety of familiar compounds like aldehydes and ketones. These compounds are not just important in chemistry labs, they are all around us. They play a big role in biological systems, food flavoring, perfumes, and even medicines. Now let's look at their physical properties. Because the C double bond O bond is polar, carbonyl compounds have strong dipole-dipole interactions between their molecules. This gives them higher boiling points than hydrocarbons like alkanes, but still lower than alcohols because they don't form hydrogen bonds with each other. They also have distinctive smells. For example, aldehydes often smell sharp, while some ketones can smell sweet. And if the carbon chain is short, they are usually soluble in water since they can form hydrogen bonds with water molecules. Moving on to their chemical properties. The carbon in the carbonyl group is electrophilic, meaning it's slightly positive and attracts nucleophiles, which are electron-rich species. This makes carbonyl compounds very reactive, especially in nucleophilic addition or substitution reaction.
Now, let's take a look at three common tests for carbonyl compound, which is Brady test, Tollens test, and Fehling test. These tests help us detect carbonyl functional group and differentiate between aldehyde and ketone. First, we have Brady test. This test uses a reagent called 2,4-dinitrophenyl hydrazine, or 2,4-DNPH, which is mixed in methanol and sulfuric acid. Brady test is used to detect the presence of carbonyl group, which is found in both aldehyde and ketone. For the observation, both aldehyde and ketone give a yellow or orange precipitate. This confirms that the compound contains a carbonyl group. However, Brady test does not tell us whether the compound is an aldehyde or a ketone. It just confirms the presence of carbonyl functional group. Next, we use Tollens test to differentiate aldehyde from ketone. The reagent used is a silver nitrate in ammonia, also known as Tollens reagent. If the compound is an aldehyde, a silver mirror forms on the inner wall of the test tube. This shining, reflective layer indicates a positive result. If the compound is a ketone, there will be no physical change. So Tollens test is specific for aldehyde and does not react with ketone. Lastly, we have a Fehling test, which also helps us differentiate between aldehyde and ketone. Fehling solution is made from a mixture of copper 2 sulfate, sodium potassium tartrate, and sodium hydroxide. Aldehyde gives a positive result, which is shown by the formation of a brick red precipitate. If we test a ketone or benzaldehyde, we will see no physical change. Even though benzaldehyde is an aldehyde, it is an aromatic aldehyde, and it does not react with Fehling solution. So remember, Fehling tests work best with an aliphatic aldehyde, not aromatic ones.
Moving on to reaction of carbonyl compound. The first one we have nucleophilic addition. The cyanide ion Cn- attack the slightly positive carbonyl carbon. The double bond to oxygen breaks and the electron moves to the oxygen, making it O-. Next, the O- picks up a hydrogen ion to become a OH-. The final product is cyanohydrine, which has both a OH group and a Cn group attached to the same carbon. The next one is oxidation reaction. At the top, we have an aldehyde. When we add an oxidizing agent, it turns into carboxylic acid. This is because aldehyde have a hydrogen attached, which make it easy to oxidize. At the bottom is a ketone. It has two R groups and no hydrogen, so it doesn't react easily with oxidizing agent, so it has no reaction. So aldehyde can be oxidized, but ketone usually cannot. Now let's look at where we find carbonyl compound in our everyday life. On the left, we have acetone, which is a ketone. It is commonly used as a solvent in nail polish remover because it evaporates quickly and dissolves nail polish effectively. On the right is formaldehyde, an aldehyde. It is widely used in biology labs for preserving specimens and is also found in embalming fluids. These examples show that carbonyl compounds are not just part of chemistry lesson. They actually play a big role in real-world product and industry.
That's all from us. Thank you.